Hey guys, so we're just going to talk about some acids and bases and just their properties and just the basic intro. So this would correlate slowly to lesson 4.5, acid, bases, and pH, but we're going to hold off and I'm going to have a separate video on the math involving pH, okay? So acids and bases, right, we got here. So properties of acids are that they have a sour taste, that they're corrosive, think like battery acid. You wouldn't want to touch that. They can be poisonous if you ingest too much of them. FYI, right? Some strong sulfuric acid will dissolve a dead body. Change the color of indicators. So we have things that will indicate whether something is an acid or a base, and we're going to talk about that here as well. Okay. Other properties of acids, right? We know that acids will react with metals in single replacement reactions, and they produce hydrogen gas. That's also known as a redox reaction, right? Acids will react with bases to produce salts. That's called a neutralization reaction. Some acids will conduct electricity, and they're known as electrolytes. We're going to talk about which acids will do those things, okay? So just as a quick review, right, we've talked about acids before when we did naming, but binary acids contain only two elements, H and one other thing, and they all have the prefix hydro. So hydrofluoric acid, hydrochloric acid, hydrobromic acid, right? Any of those things. We also know that there's oxyacids that are made with polyatomic ions. Remember, I ate something icky and Sprite is delicious. An oxyacid has a hydrogen, oxygen, and a third element, which is usually a nonmetal. So chloric acid or phosphoric acid, nitrous acid, things like that. But you'll notice that all those acids start with H, right? Bases have a bitter taste. They're also corrosive. They can hurt you just as much as a strong acid would. And they also change color in the presence of indicators. Okay. They're slippery to the touch. Bases like to react with acids, and they produce salt and water in a neutralization reaction. And they can also conduct electric current. They're electrolytes. And we'll talk about which ones of those do that. So acids and bases are both aqueous in solution, which means they will dissociate, okay? And that dissociation is going to be important. An acid is a chemical compound that increases the number of hydrogen ions in aqueous solution. Now we simplify it to hydrogen ions, but really it's going to be reacting with the water. Remember, aqueous means in water. And it's really going to be producing hydronium ions. However, we don't really use that a lot. That's like what's really happening, but we just shorten it to H plus for short. And it's just easier to think about and draw. Okay. A base is a substance that will increase the concentration of hydroxide ions in solution. So as we saw in the desmos, right, a lot of those bases all end in OH, but not all, okay? The strengths of acids. So acids have relative strength. That can go with their concentration. So obviously the more concentrated, the higher the molarity, the more strength an acid has. 16 molar hydrochloric acid is way stronger than 2 molar hydrochloric acid. But other things that deal with strength are the way that it dissociates in solution. So the strength of an acid depends on the number of hydrogen ions present in solution. A strong acid is one that ionizes completely, so a complete dissociation. So you can see here in this image we've got H bonded to Cl, right? But really what happens is when it's added to water, those H pluses and Cl minuses completely dissociate, and you have 100% ionization, 100% dissociation. That would conduct electricity, those ions that are free to flow, and that would become an electrolyte, okay? Other strong acids are like sulfuric acid, hydrochloric acid, nitric acid, hydrobromic acid, things like that. But weak acids they are a weak electrolyte, okay? So acetic acid is also known as vinegar, okay? So vinegar is an acid known as acetic acid. And acetic acid doesn't really have this formula. They're simplifying this greatly here. But if you look up acetate on your yellow sheet, it's CH3CO2 It has a negative charge. But with an H attached, it wouldn't have that negative charge. That's called acetic acid. So weak acids do not completely dissociate in water. So it partly dissociates. So this H dissociated from this acetate, but these are still bonded, okay? So there's only partial ionization. There's a little bit, okay? It's a weak electrolyte, but it's not a strong electrolyte. Okay, so that's the difference between a weak and a strong. And so here's acetic acid down here at the bottom. If this H right here leaves, this would form acetate ion. So weak acids are like HF, phosphoric acid, hydrosulfuric acid, or cyanic acid. The strengths of bases are similar to that of acids. Again, concentration is going to have a huge part in that strength, but also strong bases that are strong electrolytes. Weak bases are not strong electrolytes, just like weak acids are not strong electrolytes. And they don't produce a lot of hydroxide ions, just a little bit, right? So there's only partial ionization that allows for that base to be a weak base. So our strong bases all have hydroxide. Calcium hydroxide, barium hydroxide, sodium and potassium hydroxide. Those are our strong bases, okay? Weak bases would be something like ammonia, NH3. So acids and bases react together in a neutralization reaction. And what ends up happening is that every acid will react with that base in a double replacement like we've done before. So the H will come and take the OH. We know that HOH is called water. Those words are backwards, I'm so sorry. And then the K and the Cl will form potassium chloride, and that is a salt. Okay, so just ignore these words down here. And there's indicators that tell us whether something is an acid or a base. So these are sensitive to the pH, and we'll talk about pH in the next video, okay? But one of those indicators is litmus paper, okay? So litmus, the litmus test, acids turn blue. Acids turn blue, litmus red. So red litmus stays red. So acids stay red, okay? If it's red at the end, acids turn red. Bases turn red litmus paper blue. Bases blue. Those go together. They both start with the letter B. And blue litmus will stay blue if dipped in blue. That stays the same color. So if I have red litmus paper and it turns blue, that's an acid. If I have blue litmus paper and it turns red, that's an indicator, okay? So red litmus turned blue, that's a base. Blue litmus turned red, that's an acid. Another indicator that we use a lot is called phenolphthalein. Super fun to have a pH-TH combination there in the middle of that word. So it's phenol and then phthalein. Acids are colorless. They're like this clear one right here. But in the presence of a base, phenolphthalein turns pink. And that's indicated in that jar right there. Another fun acid-base indicator is red cabbage juice. So red cabbage, if you boil it and you want to smell cabbage, and then you could test different things around your house, but it actually changes the color, right, based on their pH. So the more red the red cabbage, the more acidic, okay, and the more sort of bluish to green color is more of a base. Excuse me. And so then we can also use just regular pH paper that isn't litmus paper, and it comes with a scale on how you can read the number of the pH, okay? And so we will pick up with pH and that math in our next video, okay? See you soon.